Okay, chapter 5, section 2 is about multiples and LCM, least common multiple of algebraic expressions. So unlike factors, listing multiples, okay? Because if I were to list factors, if I were to list the factors of a number, like let's say I list the factors of 24. Well, 24 has a finite number of factors. It has 1 in itself, it has 2 and 12. I like to do factor pairs. That's why I'm kind of setting it up like this. 3 and 8 is a factor pair, 4 and 6. So those are all the factors of 24. There are one, if I were to list them out, 1, 2, 3, 4, 6, 8, 12, and 24. It has a lot of factors. Okay. So, um, but unlike factors, listing multiples, that's infinite. There is no end to the number of multiples we can have, like or the number 8. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, right? We can just keep going. Times 8 times 6, 8 times 7, 8 times 8, times 9, times 10, times 11, times 12, right? But ellipsis there at the end because that means infinity, right? It keeps going and going and going and going. So multiples go on forever. So an expression that is a multiple of two different expressions is called a common multiple of those expressions. The smallest numbers that they have in common, that's what we're really going to focus on here. Those are called least common multiples. I find that a lot of times most people have kind of an easy time figuring out what common multiples are. Sometimes the tricky part is making sure we found the least common multiple, the LCM. And if they apply to fractions, we call it LCD, least common denominators. All right, so find the LCM of each group. Well, one way to do this is just to list them out, right? Just list, so you got 9, and I'm listing out multiples of 9. So 9, 18, 27, 36. And sometimes, depending on what you're doing, you probably realize what it is already, but I'm going to list out a bunch anyway. So you got 18, multiples of 18 are going to be 18, 36, 54, 72, 90. They keep going, right? They go on and on and on. But we're looking for the least common multiples. So they both have 18 in common, right? They both also have 36 in common. Actually, they have every multiple of 18 in common. They have 54 in common, right? I didn't go that far with 9, but they have 72, right? So if you look at the 9s, they have every other multiple of 9 in common, and they have every multiple of 18 in common because 18 happens to be a multiple of 9, so that's going to happen, right? So the LCM for that one, the LCM, if it's not clear already, is 18, right? The CM, right? The common multiples are, 18, 36, 54, 72, 90, all those numbers. But we're focusing in on the least common multiple. All right, 12 and 30. 12 and 30, just use the listing method here. You got 12 and we got 24 and 36 and 48 and 60 and 72, 84, 96, 108. Keeps going, right? Just keeps going and going and going. All right, multiples of 30 are 30, 60, 90, 120, 150, so on and so forth. All right, what do they have in common? They both have 60 in common, don't they? They both have 60 as a common multiple. So I didn't go far enough with 12, but they both have 100, if I didn't do 12 times 10, but because the next multiple of 12 is 12 times 10, which is 120. They both have 120 in common, right? But that's not the lowest common multiple. That's not the least common multiple. That's a common multiple, right? The thing that we're focusing in on is the LCM, all right? The LCM is 60 right here. All right, the least common multiple of 5, 30, and 75, all right? So listing out multiples of 5, 10, 15, 20. Now, I can keep going, but it's going to definitely have to be over 75 because 75 is the biggest number. So I'm going to kind of skip a few. I'm going to go to 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130, 135, and so on. All right, multiples of 30 are 30 and 60, 90, 120, 150. All right, 180, 210. All right. And then I should probably keep going with the fives, by the way. I'm gonna go back up. Sorry if I'm going back and forth. I'm gonna do 140, 145, 150. Okay. And then 75 times 1, 75 times 2. I'm gonna stop there because this is why I wanted to keep going with the fives, because they all have 150 in common. So sometimes I think when you're dealt with a lot, let's say you have to find the LCM of more than two numbers, what I would do is I would start with the larger numbers, start with 30 and 75. And then the smaller number, like 5 is not a difficult number to kind of work out. That was kind of a pain in the butt to have to write them all out. But I think you could probably realize, oh, 5 is a multiple of 150, at a certain point, and you can just kind of stop there without having to write out 100 different multiples of 5, because that's kind of an arduous process. So if you can avoid that, do so. All right, moving on. When multiplying or dividing blank numbers, all right, first, let's do this. So multiplying or dividing mixed numbers, first convert the mixed number into an improper fraction. Also known as, I've had people call it this, they call it upside down snowman. I don't know why. That is a very untechnical way of describing an improper fraction, but all right, whatever. All right, so right here in our first example, we've got a mixed number, negative 13 and 1/5 being multiplied by 5. All right, I'm going to go ahead and just write 5 as a fraction, like that. So let's convert to mixed number, right? Oops, convert to improper fraction, I should say, from a mixed number. All right, so negative. Now, when you convert 13 and 1/3, ignore the negative while you're converting it. So we're going to do 13 times 3. I know it's negative 13, but negative 13 times 3 is 39. All right, and then add 1. So you're going to do 39 plus 1, which is 40. All right, then tack on the negative back onto it, okay? So that's going to be, just going to write there, negative 40 over 3, okay? And then we're multiplying fractions, so we don't need to flip anything, because sometimes people get flip crazy whenever we start talking about fractions and reciprocals and all that. But since this is not a division problem, this is just a straightforward multiplication problem from the get-go, right? It's a multiplication problem, so we do not flip the second fraction, only do that for division of fractions. All right, And cross cancel, if you can. I don't think there's any cross canceling we can do on this one. So we'll just multiply left to right. That's it. Just multiply left to right. It's a very easy process to multiply fractions and divide as well. Division, a little bit, it's an extra step there, but not that hard. All right, so we get negative 40 times 5. That's negative 200 over 3. All right, we can just leave it that way. Negative 200 thirds, that's fine. All right. You know what? I might as well show you. You know, if you have to change it into a mixed number, I'm going to do top divided by the bottom. All right. And we know this is going to be negative, so I'm just going to put a negative up there. All right, and start dividing. So 3 divides into 20 6 times, right? 7 would be too much. That'd be 21. So 6 times 3 is 18. Subtract, and you get 2. Bring down another 0. All right, bring down, well, we haven't brought down any zeros. So bring down a 0. 3 goes into 26 times again, and you get 18 again, and you get 2 again. But there's nothing else to bring down, so that becomes your remainder. So 2 over 3. So that would be fine. So negative 66 and 2/3 is fine too. All right, next one here. All right, let's convert to improper fractions. If it's a mixed number, convert it. So while you're doing that, ignore the negative while you're doing that. So 5 times 12, 5 times 12 is 60. 60 plus 4 is 64, then put the negative back on. So negative 64. So put the negative back on there, okay? And then negative 64 fifths. And then think of this as over 1, so negative 8 over 1. Now, nothing has been flipped yet. Now, this is a division problem, so we are going to flip. So we're going to keep the first fraction the way it is. We're going to change multiplication or division into multiplication, change it into multiplication, and we're going to flip negative 8 over 1 into negative 1/8. Notice like when I flip fractions, I typically don't worry about flipping the sign. I like to, I don't know if you've noticed this, but I like to keep the negative in the numerator. That's just kind of a habit I get into. It really doesn't matter where you keep it. All right. But now we have a negative times a negative, which is a positive, right? That's a positive. All right. So we know that this is going to come out positive. So here we could do some cross canceling here, which I think would be wise. So we could divide by 8. So 64 divided by 8 is 8. 8 divided by itself is 1. So 8, all we got to do now is just 8 times 1. 8 times 1 is 8. 5 times 1 is 5. All right, and you can write that also as a mixed number as 1 3/5. Oh, and I forgot here. Change division into multiplication. All right, now right here, there's no boxes or anything. This is a free form one where you just got to do it yourself. But yeah, we've got mixed numbers in both parts of this problem. So let's change everything into improper. You got to do this when you're multiplying and dividing fractions. It's actually not a bad idea if you're adding or subtracting. You're going to find that, especially, like when we get to it, but it's a really good idea to do it when you're adding or subtracting, especially for subtraction, because regrouping is super confusing for people. So anyhow, let's change it. So 4 1/4 is, what's that? 17/4, right? 17/4. I'm not flipping anything. I'm just going to take one step at a time. 2 times 2 is 4. 4 plus 1 is 5. I'm going to put negative because there's a negative there, right there. Negative 5 over 2. All right, now we're going to flip. So keep the first fraction the way it is. Flip or change division into multiplication. And then flip negative 5 over 2 to negative 2 over 5. And now these numbers can be cross-canceled right there. We can change that into negative 1 because we can divide by 2. I shouldn't pass that up. We're dividing by 2. And that can change into a 2. And then what do we have? We have negative 17 over 10, or negative 1 7/10. Both answers are perfectly fine. All right, here's a couple more where you can just pause the video and do them on your own. See how you do, and unpause it. See how you see how it came out. Okay. So, all right, I'll just go ahead and just do these. I'm not really going to talk. I'm just going to go through them. Okay, so on the first one for A, I got 27/4 or 6 3/4, and on the other one I got negative 105/16. Actually, I should change that into a mixed number as well in case you did that. So 105 divided by 16. I know it's negative, but I'm just going to put a negative up in the quotient. So 16 times, I think 16 times 6 is 96. Yeah, so that's 96. So I'm going to put a 6 up in the quotient here, 6, and I'm going to put 96 here. And then when you subtract, you get 9. So 6 and 9, or negative 6 and 9/16, if you wrote it as a mixed number.